Picking up where we left off, in example 5, our instructions are giving us a hint to rewrite the whole equation in terms of one trig function. So we notice that we have a sine squared and we have a cosine. And on your reference sheet, you have a Pythagorean identity that tells you sine squared plus cosine squared equals 1. So that means that 1 minus cosine x in this equation is going to equal 2 times 1 minus cosine squared of x. And since I'm going to have a squared term in this equation, I'm going to distribute that and then bring everything over to the left-hand side. So 1 minus cosine x will equal 2 minus 2 cosine squared of x. Bringing everything over, I have 2 cosine squared of x minus cosine x minus 1 equals 0, which I then factor. So when we do, we have 2 cosine x and cosine x and plus 1 minus 1. And the reason why I know that my minus goes here is because notice that if we were to FOIL this all out, the 2 cosine x would be negative combining with a plus 1 cosine x, giving me this negative cosine x. So setting up those two expressions now equal to 0, I have 2 cosine x plus 1 equals 0, or cosine x minus 1 equals 0. In the first equation, when I subtract 1 and divide by 2, I have cosine x equal to negative 1/2. In the second equation, I have the cosine of x equal to 1. So x equals the arc cosine of negative 1/2 or 1. Oops. Or the arc cosine of 1. On your reference sheet, you're looking for an x-coordinate of negative 1/2 or an x-coordinate of 1. That happens at x equals 0, at 2 pi over 3, and at 4 pi over 3. And so those are your solutions. You might want to take a moment to pause your video and write everything down, since I need this space in order to do part B. In part B, I have everything in terms of cotangent squareds and cosecant squareds. And so you know from your reference sheet that there is a Pythagorean identity relating the two of them. So you really just need to pick. Myself personally, I'm going to substitute 1 plus cotangent squared in for cosecant squared. So I'll have cotangent squared of x times 1 plus cotangent squared of x plus 2 times 1 plus cotangent squared of x minus cotangent squared of x equals 2. So I've got some distributing and combining like terms to do here. When I do that, I'll have cotangent squared of x plus cotangent to the 4th of x plus 2 cotangent squared of x minus cotangent squared of x equals 2. Combining my like terms, I have, when I put this in standard form, I'll have cotangent to the 4th of x plus cotangent x and plus 2 equals 2. Subtracting the 2 from both sides, I'll have cotangent to the fourth of x plus cotangent, whoops, that's squared, of x equals 0. I can factor out a greatest common factor of cotangent squared of x and get cotangent squared of x plus 1 equals 0. And now I've got two separate expressions set equal to 0, and I'm going to solve those equations. So cotangent squared of x equals 0, or cotangent squared of x plus 1 equals 0. In this second equation, the one on your right, when I subtract 1 from both sides, I have cotangent squared of x equal to negative 1. And if you try taking the square root of that, it doesn't work. Taking the square root of a negative number, we can't do that. So now I just have to find the arc. Oops, let me take the square root of both sides in this equation. I'll have cotangent of x equals 0. Now, in previous examples, when I had the maybe cotangent, cosecant, or secant, I flipped it over and then went to my unit circle. Here, I can't take the reciprocal of 0. That's undefined. So I need to look at my reference sheet on the left-hand side and realize that cotangent of theta equals x over y. So what I'm looking for is somewhere on my unit circle, x over y equaling 0. What I'm basically looking for is an x-coordinate of 0. So where do I see x-coordinates of 0? I see them at pi over 2 and 3 pi over 2. And those are our solutions. In example 6, my instructions are telling me to solve by squaring. So I'm going to square both sides of this equation. When I do, please make sure that you remember secant of x plus 1 quantity squared is not secant squared plus 1. I have to FOIL that. So I'll have secant squared of x plus 2 secant x plus 1 equals, and then on the right-hand side, so that everything is in terms of one trig ratio, I'm going to replace tangent squared with secant squared of x minus 1. And conveniently, those cancel out. So now I have 2 secant of x plus 1 equals negative 1. And if I solve for secant of x, I'll have 2 secant of x equals negative 2. So secant of x is negative 1. I can make this a little bit easier on myself by taking the reciprocal of both sides. So that's cosine of x equal to negative 1. And x is the arc cosine of negative 1. So I'm looking for anywhere on my unit circle where my x-coordinate is negative 1. That only happens at pi. Something you want to be mindful of. Anytime you square an equation in order to solve it, think way back to algebra when you solved radical equations. You had to go back and check for extraneous solutions. So that's what we'll do here. We're going to check if the secant of theta plus 1 does in fact equal the tangent of pi. I think I may have said theta on the left-hand side. All right, so I'm checking to see if the secant of pi is plus 1 equals the tangent of pi. So secant is the reciprocal of cosine. So I know it's going to be the reciprocal of the x-coordinate at pi. And the reciprocal of the x-coordinate is negative 1. So that's just negative 1. And does -1 plus 1 equal the tangent of pi? So tangent, remember, is y over x. So at pi, when I take y over x, that's 0 over 1. So this does work out. So yes, x does equal pi. Once again, you probably want to pause your video to copy everything down since I need to erase in order to do part B. In part B, once again, I'm squaring that. So I'll have cosine squared of x equal to sine of x minus 1 times sine of x minus 1. When I FOIL out the right-hand side, I'll have sine squared of x minus 2 sine x plus 1. On the left-hand side, cosine squared is equivalent to 1 minus sine squared, which means this time my squared terms aren't going to cancel out, so I want everything on the right-hand side so that my squared terms are positive. So that is 0 equal to 2 sine squared x minus 2 sine x, and the 1's cancel out. At this point, I can factor this expression by factoring the greatest common factor of 2 sine x out. When I do, I'm left with sine x minus 1. Setting up my two equations, or two expressions now equal to 0. 2 sine x equals 0, or sine of x minus 1 equals 0. So sine of x equals 0, or sine of x is 1, which means x is the arc sine of 0 or the arc sine of 1. On my reference sheet, I'm looking for where do I see a y-coordinate of 0 or 1. That happens a few times. It happens at 0. It happens at pi over 2, and it happens at pi. So now the last thing I need to do is check whether they are actually making my equation true. So I'm going to run out of space here, and therefore I want to write the equation down again. Cosine x equals sine of x minus 1. I am checking. Is the cosine of 0 equal to the sine of 0 minus 1? Well, the cosine of 0 is 1. The sine of 0 is 0, and 0 minus 1 does not equal 1, so 0 is out. Check the rest of them. Is the cosine of pi over 2 equal to the sine of pi over 2 minus 1? Well, the cosine of pi over 2 is 0. Does that equal the sine of pi over 2, which is 1, minus 1? Yes, it does. So this is good. Finally, check if the cosine of pi equals the sine of pi minus 1. Cosine of pi is -1. Sine of pi is 0, and 0 minus 1 does equal -1. So those two solutions are our answer.